in the last class we were discussing exothermic reaction and endothermic reaction on the basis of Born energy, right? I told you there are two definitions of exothermic reactions. Like I mean to say that you can define exothermic reaction in two ways. The first one is that they release energy, and the second one is that more energy is released than absorbed. And you can define endothermic reaction in two ways. Like I can say that more energy is absorbed than released. Okay. Then I gave you some questions. Okay, and also I have shown uh, like past paper question in which the bond energy were given to you, and you have to calculate the bond overall bond energy. So the formula is reactant minus product. So the formula is reactant minus product. I mean to say that bond breaking minus bond making. Okay, bond breaking minus bond making is the formula to calculate the overall bond energy. And if you are getting overall answer like positive answer, so you can tell that the reaction is endothermic. And if you are getting overall like the negative answer, so I can say that the reaction is exothermic. Okay, so this was all about the bond energy. Okay, examiner would be giving you the relative data. Let's suppose I have shown the question in the last class. In that question, like there were written that you can use the data booklet to show like to have the different bond energies, like the value of CH bond, and also N triple bond N, and O double bond O, then H single bond H. Then after looking at the bond energies, then we have to use the formula, that is reaction minus product. After putting the values, then we would be having the final answer. Okay, we did this thing in the last class. Okay, so in today's class we are going to discuss enthalpy change. We are going to discuss enthalpy change. Okay, enthalpy change, enthalpy change, enthalpy change, right? So enthalpy change means that enthalpy means energy change. It's what? It's energy change basically, right? It's energy change. Okay, it's energy change, right? Huh? Enthalpy change means that, like in any chemical reaction, we have reactants and we have products, right? We have reactants and we have products basically. So we are supposed to break down the bonds in a reactor side, and we are supposed to make the new bonds in the product side, right? Okay, so there would be an overall energy change, obviously. That would be called enthalpy change. That would be called enthalpy change, right? So we have, this is the energy difference between reactants and products. Reactants and products. Okay, if and then we have standard standard enthalpy change. Delta H naught. delta H naught. Standard conditions are standard conditions are temperature is equal to 25 degrees Celsius. Okay. Pressure is equal to 1 atm. Okay. These are called these are called standard conditions. Okay. We would be measuring the energy change. We would be measuring the energy change at standard condition. Okay. We would be measuring energy change at standard condition. So basically, what is standard enthalpy change? What is standard enthalpy change? I can say that it's a measurement. It's a measurement. It's a measurement in change in energy. Measurement of change in energy when reactant changes into product under standard conditions. Under standard conditions. Okay. Uh, and remember, the concentration is 1 mole per decimeter cube. Concentration is mole per decimeter cube, right? Concentration is mole per decimeter cube. Okay. So just give me 1 minute. Wait. Okay. Uh, okay. So this is standard condition. So we would be measuring energy change under these conditions. That's why this is called standard enthalpy change. Okay. Um, we would be measuring different enthalpy changes. We would be measuring different enthalpy changes. Okay, different enthalpy changes. Let's suppose the first one is its standard enthalpy change of formation. The first one is standard enthalpy change of formation. Delta HF. Standard enthalpy change of formation. So what is standard enthalpy change of formation? Basically, this is an enthalpy change. This is an enthalpy change when one mole of a compound is formed. When one mole of a compound is formed from its elements, from its elements in their standard states, under standard condition. Like let's suppose I have to make this water. I have to make this water. Standard and standard state for water is liquid, right? So according to the definition, when I would be forming one mole of a compound, this is a compound, this is a compound, this is liquid, right? This is liquid, okay? This is what? This is liquid. This is liquid. So when I would be forming water in liquid, so basically um, I need to have hydrogen gas. I need to have hydrogen gas. So because the standard state for hydrogen is gas, and also it's diatomic, right? This is O2 gas. This is O2 gas. Okay. So from its elements, from its elements in their standard states. A standard state is gas. Standard state is diatomic. It's not monoatomic. You are not supposed to write only H. You are not supposed to write only O. It's H2 and O2. It's H2 and O2, right? It's H2 and O2. So then I have to balance this equation. I am supposed to write half over here. Okay, so they would be cancelled each other. And then the remaining, this is your balanced chemical equation. You are not supposed to write this equation in this manner. See this. You are not supposed to balance in this manner. You are not supposed to balance in this manner. Can you tell me why this is wrong and this is right? Can anyone tell me? Yes? Mm-hmm. Can anyone tell me? Mm-hmm. Yes, Hadia Muzaffar, Tala, Irtaza, Usman, Roha, Samir, Soha. Yes. Why the second equation is incorrect and the first equation is correct? Yes, Samir. What do you think, Samir? Mm-hmm. Bolo, Samir. Mm-hmm. Usman. Sorry, but it's not balanced. No, this is not a reason that it's not balanced. Not balanced. No. Basically, you are supposed to tell that according to the definition, when one mole of a compound is formed, according to the definition, when 1 mole of a compound is formed, right? So I am supposed to have 1 mole in the product side. I am supposed to have 1 mole in the product side. I am supposed to have 1 mole in the product side. 1 mole in the product side. Okay, this is incorrect. This is incorrect. According to the definition, they are saying that we are supposed to have 1 mole of a compound is formed. This is 2 moles. This is 2 moles. This is 2 moles. That's why technically this equation is incorrect. This is not satisfying the definition. This is not following the definition of enthalpy change of formation. That's why the equation A is correct. That's why the reaction A is correct. Always you need to form 1 mole of a compound. Always you need to form 1 mole of a compound. Let's suppose I'm asking I need to form sodium carbonate, and this is solid. Standard state for sodium carbonate is solid. So can you tell me, according to the definition, 1 mole of a compound is formed from its elements. From its elements. Element is sodium. Element is carbon. Element is oxygen. Can you tell me in the reactant side what am I supposed to write? Yes? Hmm? Yes? Anyone? Hmm? Roha, can you tell me, Roha? Roha?
Sir, is it going to be sodium and carbon monoxide separately?
Uh, See the definition. From its elements, not a compound, not a compound, not a compound, not a molecule, only elements. Okay? So this
So
is
sodium?
sodium. I need to have sodium solid. Standard state for sodium is solid. I need 2 sodium. Then carbon. The standard state of carbon is solid. I need 1 carbon. Standard state for oxygen is O2 in the form of gas. How many oxygens I need? How many oxygens do I need? So you will say, sir, 3 oxygens. I would be writing 3 over 2. 3 over 2. Okay. So this is what the enthalpy change of formation. This is also standard enthalpy change of formation. It may be positive, it may be negative. Examiner would be giving you the values, then you would be solving. After the solution, you would be deciding if the answer is negative, so you can say that the reaction is exothermic. And if the answer is positive, you can say that the reaction is endothermic. Okay, so on the basis of the sign of the answer, you would be deciding basically. Okay, let's suppose um I need to form C2H5OH. C2H5OH. Standard state for ethanol is liquid. This is alcohol. This is alcohol. Can you tell me how am I supposed to prepare ethanol by using different elements? According to the definition, when 1 mole of a compound, this is one, it should be one. Okay, this is fixed. This is fixed. I cannot change. We have to form one of its elements. Can you tell me what type of elements am I supposed to write over here in the reactant side? Yes. Mm-hmm. Yes. Taha, Shamir, Shahid, Samir, Muhammad Ahmad, Tala, Zaina, Irtaza, Hadia Muzaffar. Yes, can you tell me this, beta? Mm-hmm.
Sir,
Hmm?
Can it be carbon, hydrogen, and oxygen?
Exactly. Can you tell me the standard state for carbon, Roha? Hmm?
It will be 2C.
Uh, but
Okay,
standard
that
state,
gas.
solid. Okay.
Okay.
And how many hydrogens do I like? Am I supposed to write, Roha? How many hydrogens am I supposed to write? Sameer, yes. Can you tell me this?
So
Mhm.
O gas.
Uh, H H
तो
gas.
परसेंटेज में करूंगा ना
Three of them.
Sameer, mute your mic. Okay. Basically, um, how many hydrogens do I need? Six
Five
hydrogens. I'm
hydrogen.
supposed to write three over here. I'm supposed to write three over here. Then I need oxygen. I need oxygen gas. So this is one oxygen. How am I supposed to make this into one? I'm going to write half over here. This is balanced equation. So the energy that is released or absorbed, that would be called standard enthalpy change of formation. Okay, standard enthalpy change of formation. Okay, this is the question from Usman. Usman, can you tell me if I have to make a C2H6? This is ethane. This is ethane. According to the definition, when one mole of a compound is formed from its elements in their standard states under standard condition, so Usman, which elements am I supposed to write in the reaction side? Yes? Mhm.
Sir, carbon and hydrogen.
Exactly. So how many carbons and what's the state for carbon?
Solid.
Okay, this is solid. And how many carbons, Usman?
Sir, 3.
How many carbons in the product side you have?
6.
Mhm. Carbons, beta. Carbon, Usman. Carbon.
2.
Two carbons. Exactly. And how many hydrogens do I need to make this C2H6? Yes. And
Uh,
what's the standard state for hydrogen? What's the standard state for hydrogen? Mhm.
Sir, gas.
Exactly. H2 gas. I need to make
And
six hydrogen
3.
atoms. Balance this equation. I am supposed to have
Sir,
3
3.
over here. Exactly. So this is what? Standard enthalpy change of formation. That would be equal to, like if the data is given to you, so then you can calculate it very easily. Okay. Now this is question from Zena. Zena, can you tell me please? I need to make H2O2, hydrogen peroxide. Yes, Zena. Which reactor am I supposed to take to make this H2O2? Yes,
So you'll have H2 gas
exactly. And then,
and O2 gas.
is this balanced?
Yes, sir. It's balanced.
Good. To make HNO3 solid, sorry, liquid. Or I can say this is aqueous. This is aqueous. Yes, Taha. Which reactant am I supposed to take to form HNO3, that is nitric acid? Yes,
Sir, hydrogen gas plus nitrogen plus oxygen
okay.
O2, 3/2 O2.
And then, These are the standard states for hydrogen gas, nitrogen gas, and oxygen gas. So to balance this equation, Taha, which number am I supposed to write?
Sir, 2HNO3 and 3O2.
Wait. This is the thing that I told you this equation is incorrect because this is 2H2O. If you ask why, see the definition. When 1 mole of a compound is formed, this is the, you can say this is the main criteria that we need to follow. Only 1 mole of a compound. You cannot write any number over here. This should be 1. 1 mole of a compound is formed. 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 So you need to make it 1, and then you are supposed to balance your left hand side. You have to change the numbers over here. This is the only thing that you can do. So now tell
Sir?
me, which number am I supposed to write in the reactant side to balance this equation?
Sir,
Yes.
1/2 H2, 1/2 N2.
Sir, can we half in H2 and half in N2 and 3/2 in oxygen?
Exactly. This is correct. Right, Taha? Shamir, are you getting my point? Muhammad Ahmed, are you getting my point? Irtaza, are you getting my point? Hadia Muzaffar, yes. Zaina, is
Yes,
that
sir.
correct? Soha? Okay, good. Mhm. And this is from Soha. Soha, this is the last question from my side related to enthalpy change of formation. Then we would be studying the next process. Yes, the compound is H2SO4. Yes, Zaina. Oh, sorry, Soha. No, not H2SO4. I need to give you this. Yes. Mhm. Sorry, it's gonna be
Carbon, oxygen, and hydrogen.
how many carbons, hydrogen, and oxygen? Yes.
2H2.
Okay. Then
2 carbon
mhm,
and 2 oxygen.
like 2 oxygen, just like this.
No, O2.
Exactly. Taha, can you tell me why I am not supposed to write like this? Yes, Taha. Can you tell me this?
Sir, gases exist in diatomic form.
Array. Nice. Excellent. This is enthalpy change of formation. Okay. So that's all from standard enthalpy change of formation. Okay.
Sir?
Someone is saying something. Yes.
Can you repeat why we did not write 2O2?
2O2, because in this product I have 2 oxygens. I need to have 2 oxygens. Okay. When I would be writing 2O2, it means that I'm going to write 4 oxygens. Okay. This is 2 oxygens, so that's why I only need 2 oxygens, so that's why I have written O2. Are you getting me? Yes or no? Yes.
Sir, I have a question.
Yes.
Is oxygen diatomic, like halogens?
Exactly.
Alright.
O2, N2, H2, F2, Cl2, Br2, I2, these all are diatomic.
There
Okay.
are
And
any other like elements which are not halogens but they're diatomic?
H2, N2, O2.
H2
H2, N2, O2.
and
Yes.
thank you.
Okay. Okay. Then we have Then we have the next process that is called standard. Standard enthalpy change of combustion. Okay. Let me tell you the definition. Um, Combustion means that sorry, when 1 mole of a substance or a compound is burned in an excess of oxygen to form respective oxides. I mean to say that, and remember, this is always exothermic, right? This is always exothermic. This is always exothermic, okay? Whenever you would be calculating the standard enthalpy change of combustion, you would be getting the negative answers always. You would be getting the negative answers always, okay? Okay, what is the difference between a standard enthalpy change of formation and standard enthalpy change of combustion? So remember, in this definition, in this process, 1 mole of a compound, this is one, this is one, this is one, this is one. Okay, this is one, this is one, this is one. But in combustion, what we are doing basically, we are going to combust, we are going to burn 1 mole of a compound. Let's suppose I have CH4, I have CH4, this is methane, it's going to be burned in the presence of oxygen. They would be forming, it would be forming its respective oxide. It would be forming its respective oxide. The oxide of carbon is CO2 and the oxide of water, the oxide of H is water. Okay, so this is called the respective oxides. So then I need to balance this equation, but remember, in this process, in this criteria, you can put any number in the product side. It should be 1, it should be 2, it may be 1, it may be 2, it may be 2, it may be 3, it may be 4, it may be 5. Don't worry about that, because in combustion we have to take care of this. It should be always 1. This is always 1. 1 mole of a compound is burned. 1 mole of a compound is going to react with oxygen. So it should be 1. This is always fixed. This is always fixed. In the formation, I used to have 1 mole of a compound, like 1 mole of a product. But in this process, we should have, we must have 1 mole of a compound. So to balance this equation, you can only do this. 1 carbon, 4 hydrogens. So this is 2 into 2, that is equal to 4. When I have written 2 over here, so hydrogen is balanced, but oxygen, if you can see, this is 2 oxygen and this is 2. So total is 4 oxygen. So then now I'm supposed to write 2 over here. So this is the balanced chemical equation. and this satisfies this definition. According to this, when 1 mole of a compound is combusted, when 1 mole of a compound is combusted, when 1 mole of a compound is formed, like is burned in an excess of oxygen, okay, to form their respective oxides. Okay. Let's suppose I have ethanol C2H5OH. Can you tell me the final equation? Yes. Can you complete this equation? Yes. Shamir, can you tell me this? You are supposed to tell me the balanced equation, right? Yes. Shamir, can you tell me this? What's the product? Nadia Muzaffar, can you tell me? Irtaza, can you tell me what's the product? And you are supposed to tell me the balanced chemical equation.
The product, I'm not sure.
Why? Because it should be dioxide and water. You must have oxides. So the oxide of carbon is carbon dioxide. The oxide of hydrogen is water. Okay, this is the product. Then you would be balancing this equation. Just like this. It should be 2. Overall, we have 6 hydrogens. It should be 3. Then how many oxygens? This is 2 into 2 is 4. This is 7. I am supposed to write 3O2 if you ask why. So this is 6 and this is 1. So total 7 oxygens. Okay. So this is balanced chemical equation and I can say that this is the enthalpy change. Did you get my point? Okay. Now tell me this. Yes, Irtaza and Sayyid Muhammad Ahmad. Can you tell me this? CS2 is going to be burned in the presence of oxygen to form the products. I'm asking what would be the product that
Carbon
would be
dioxide and sulfur.
exact carbon dioxide and what?
Sulfur. S2. SO.
Dioxide. Sulfur dioxide. What I told you to form respective oxides. Respective oxides means that if you have carbon, so carbon dioxide would be formed. If you have nitrogen, so nitrogen dioxide would be formed. And if you have sulfur, so sulfur dioxide would be formed. If you have phosphorus, so phosphorus oxide would be formed. If you have silicon, so silica would be formed. So basically, in combustion, you need to react your sample with excess of oxygen. If the sample is being combusted in the presence of oxygen, if the sample is being burned in the presence of oxygen, okay, so they would be forming their respective oxides. Like let's suppose sometimes you would be having phosphorus, sometimes you would be having sulfur, hydrogen, oxygen, nitrogen, aluminum, like all of this stuff. So you would be forming their respective oxides. That's very easy criteria to complete this equation. Okay. So I need to balance this equation. This should be 2.
So it'll be 3O2.
2 and 2, 4. So 4 plus 2, 6. So it should be 3 into 2 is 6. Okay. So this is the balanced chemical equation, and also this is standard enthalpy change of combustion. I am not supposed to write any number over here. This is 1. Must be 1. It must be 1. Okay. Must be 1. So this is all about the combustion reaction. Okay. Let me tell you something. Um, let me tell you something. Combustion of hydrogen. Can anyone tell me, please? Yes. Combustion of hydrogen. Yes. Usman, can you tell me this? Combustion of hydrogen. It means that hydrogen is going to react with oxygen. It means that hydrogen gas is going to react with oxygen gas. Can you tell me what the product would be formed as a
Sir,
result of this reaction?
water.
Exactly. Exactly. But this is quite confusing. This is quite confusing. But how you would be balancing this equation? Yes, Usman, you have to balance this equation as well. So what's the number you are supposed to write? Yes.
Uh, Sir, 2 in the product side, and then
Okay.
2 in the hydrogen for reactant side.
Now balance, right?
Yes, sir.
Technically, this is wrong.
So it can't be
Uh,
like multiply O2 by half.
Ah, I told you the definition of combustion. See the condition. See the condition. 1 mole of a substance. You must have 1 mole of a substance. 1 mole of a substance. Remember, you are not supposed to write any number over here. You are not supposed to write any number over here. This should be 1. This should be 1, right? So then we have to balance this equation just like that. Just like that. This is balanced. This is 1 mole of H2. So 1 mole of a compound is combusted, is burned in an excess of oxygen. 1 mole of a compound is burned in an excess of oxygen. So this is called 1 mole. You are not supposed to write any number over here. You are not supposed to write any number over here because this is what the standard enthalpy change of combustion. Okay. What if I'm asking from Soha and Taha Riaz? Beta, what if I'm going to write in this manner? I'm going to write in this manner. I'm going to write in this manner. Let's suppose I'm just balancing this equation in this manner. Can you tell me this, the name of the process? May I say that this is a standard enthalpy change of formation? If no, then why? If no, then why? Yes, Soha, can I say that this is a standard enthalpy change of formation? Mhm.
No, sir.
No, because this is 2. This is 2. It should be 1. It should be 1 for formation and it should be 1 for combustion. It should be 1 for formation. It should be 1 for combustion. This is very important to know. Okay, this is very important to know. So this is all about standard enthalpy change of combustion. Okay, this is all about standard enthalpy change of combustion. Then uh, we would be discussing the different processes later on. Okay,